This demonstration will show a live attack based on the recently reported cyber attack on a Florida water utility. While not all the details have been publicly disclosed, we will show you how this could have been perpetrated using vulnerable email and remote desktop tools. This attack was frightening because of how close it came to harming public safety. Like most attacks, this involved multiple steps in the attack kill chain. We will demonstrate both how the attack may have been perpetrated using real hacking tools, and we will also show you how Virsec can stop these exploits at multiple points. This diagram summarizes what you'll see. First, we'll show how a phishing email hooked a legitimate user's browser, downloading malware to steal the user's TeamViewer password. Next, we'll log into TeamViewer with stolen credentials and install a malicious DLL, exploiting a vulnerability in TeamViewer itself. From there, we'll install more malware on the workstation, migrate to an admin process, and install a keylogger to extract passwords from a legitimate user logging into the SCADA HMI. Finally, with these stolen credentials, we'll be able to access the SCADA web interface and gain control over this critical system. At multiple points, we'll show how Virsec can stop critical stages of this attack kill chain and could have prevented downstream damage. So let's see this in action. Here is the attacker's dashboard. On the lower left is the terminal the attacker will use to attack the victim's laptop. On the top right, you'll see a session that the attacker will use to connect directly to the SCADA server. This attack starts with a spear phishing email targeted at a specific user. On the victim's laptop, here's the email, posing as a benign message from the marketing team, but it includes a malicious link. When the user clicks on that link, it will take us to a web page that contains the malicious hook. Now, from the attacker's browser, you can see that the victim's browser is hooked into the Beef control panel. We'll use this to send the user a fake Adobe Flash notice. When the user clicks on it, it will install the malware. This malware will start a keylogger in the victim's machine so we can steal credentials. When the user is asked to authenticate to the server, the attack will sniff and steal these credentials. Here you can see the username and password in the attacker's console. Now we can log into the victim's machine and connect to the TeamViewer application. This also connects us directly to the SCADA system. From here, we'll download a malicious DLL into the TeamViewer application, exploiting the vulnerability. When we restart the service, we'll open a command shell into the SCADA system. We'll also migrate into an admin process to remain hidden, and we'll start another keylogger. Now we'll be patient and wait for a legitimate admin user to log into the SCADA workstation, and we'll be able to steal those credentials with our keystroke sniffer. You can see here when we dump the data, here are the stolen usernames and passwords that give us direct access to the SCADA system. Now comes the scary part. With these credentials, we now have direct access to the SCADA workstation, a critical industrial control system for the water plant. From here, a knowledgeable attacker can change settings, disable safety features, or bring down entire systems. Reportedly, in the Florida attack, the attacker was changing the lie levels in the water system from normal to dangerously high levels. If this hadn't been spotted in time, the results could have been disastrous. But now let's bring Virsec into the picture and show how it can stop this attack directly at the SCADA layer. In the Virsec control panel, we'll activate host monitoring for the SCADA server and restart the service. Now when the attacker tries to install the malicious DLL, Virsec instantly detects and stops this, preventing the attacker from hijacking control of the workstation. Back on the Virsec console, let's look at the incident. Here you can see we have detected the attempted DLL injection and captured detailed forensics on the incident. You can also see that we have taken an automatic protection action to suspend the process. This is where Virsec offers critical protection. While conventional security tools try to stop bad traffic from entering, they can only stop what they've seen before and fail to detect and stop this type of attack. Virsec instead uses a different model. Our application-aware technology maps precisely what an application is allowed to do and instantly stops any deviations regardless of the source, with no prior knowledge. At the end of the day, this is what's needed to provide effective defense against this type of advanced attack.